All right, so let's talk about a theoretical domain versus a practical domain. As we know, domain are the set of input values. So theoretical domain are the mathematical values that can be put into a function. So in general, normally it's all real numbers. Normally, pretty much any number can be put into a mathematical function. Remember, the symbol for that is 2 lines and make an R out of it, all real numbers. However, there are 2 rules that you cannot break. First, you cannot divide by 0. So we will exclude numbers that divide a function by 0. And then the second rule that you can't break is that you cannot take the square root of a negative number, because we know that creates an issue with imaginary numbers. So as long as you don't break these 2 rules, the theoretical domain will be all real numbers. However, if for some reason a number would divide by 0 or square root a negative number, then we will have to change the domain. So the practical domain are the values that make logical sense to be put into a function. We only have a practical domain when it's a word problem. Because for word problems, there's numbers that just don't make sense. Like, for example, remember when we had f of period equals room number, that function? That function assigned a period of the day to a room number in which that class would occur. So we talked about how f of -6 didn't make sense because you can't have a negative period. So for this, the practical domain would have been only the numbers from 0 to 9. And actually, 0 wouldn't make sense because we don't have a period 0. So really, it only would make sense from 1 to 9. So only the numbers from 1 to 9 would make sense from a logical standpoint. Anything after 9, we don't have a 10th, 20th, 200th period. Anything below 1, like -6, we don't have a negative period. So the practical domain would be only the values that make sense. The theoretical domain, since I'm not breaking any math rules with this function, would be all real numbers, because theoretically you could put any number in here. It's just practically speaking, it would only make sense to go from 1 to 9. So let's take a look at this first example. Our parents are going to pay us $4 per chore we do around the house. We also get in a weekly allowance of $10. Write a function that shows how much money you have, M, if you do C chores. I'm going to also add in that you only do up to 13 chores per week. So the most number of chores you're going to do is 13, because anything beyond that is a little ridiculous. So the independent variable, what you control, is the number of chores you do. The dependent variable is M, the amount of money you earn. So to write it with function notation, it would be M of C. The independent variable always goes inside the parentheses. The dependent variable always goes outside. And to calculate how much money you would make, you're making $4 for each chore, and you have the $10 allowance. So theoretical domain, what mathematically can go into this equation? I'm going to check in with my rules. Am I dividing by 0 or taking the square root of a negative number? I'm not. So my theoretical domain is all real numbers. My practical domain, though, is what can go in for C, what makes practical sense. Well, I can't do any negative chores. It wouldn't make sense to put a negative number in for C. So the least number of chores I could do is 0. Oh, and I shouldn't put the letter X. Normally we put the letter X for domain because it's an input, but here our input is C. So I want to make sure my variable matches my my formula. So C, and then the most number of chores I told you was 13. We can't put 1,000 in for C. You're not going to do 1,000 chores in a week. So the only values that make sense are the ones between 0 and 13. And just to add in a little side note, you can't really do a fraction of a chore. I guess you could half do the dishes, but you're not going to get paid for that. So C can only be an integer. It can only be a whole number. This symbol is kind of like all real numbers, but this symbol means all integers. So this literally says C is only an integer. This symbol basically means is in math, is part of. This little piece right here, this is just kind of bonus information. This is what I'm looking for. The least amount of chores you can do is 0. The most is 13. If you think to add this in to show that you can only have it be 0, 1, 2, 3, 4, that would be great. All right, so for this next one, you have 50 pieces of candy splitting amongst your friends. So C is the amount of candy each friend gets. F is the number of friends you have. So F is going to be my independent variable. I control how many friends I share with. My dependent variable is the amount of candy each person gets. So to calculate the amount of candy with an input of friends, I'm going to divide 50 by F. So for theoretical domain, I'm just looking at this formula. This formula, in theory, anything can go in for F except the number 0. The number 0 can't go here because then I would get a no situation. I would be dividing by 0. So my domain is all real numbers except F cannot equal 0. Because if F were to equal 0, I would be breaking my number 1 rule that I can't divide by 0. So that's our theoretical domain. Any number except it can't be 0. My practical domain is what makes sense logically. First of all, I have to have at least one person to split it with. And then the most that I can split it with would be 50, because I don't want to split a piece of candy in half. So it wouldn't make sense to split it with any more than 50 people, since that's the number of candy that I have. And notice how F matches the variable. I didn't do X. And if, again, you want to say that F has to be an integer, because nobody has half of a friend, technically, you could add that in as well, just to add that little stipulation that friends can only be a whole number or an integer. All right, so now we have an escalator lifting or lowering a person at 0.87 feet per second. Toby is going down from the second floor. So write a function to represent his height after S seconds. So his height is out of his control. The seconds, how long he's on there, is what he does control. Time always tends to be the independent variable, as you've seen in your science classes. The dependent variable is his height. So his height as a function of seconds is equal to the 60 feet he starts at minus the 0.87 feet per second that he's decreasing by. In theory, S can be any number. So the domain is all real numbers for this one in theory, right? I'm not dividing by 0, and there's no square roots here. So it can be any number. The practical domain is going to be that, of course, starting at 0. He can't be on there for negative time. And let's see, how long is it going to take him to ride the escalator down? So if I ride it for the entire length, to figure out how many seconds that would take, I would divide. That's equal to about 68.97. So it's going to take him this many seconds to get to the bottom. Anytime after this, he's going to be in the ground, right? He's going to be on the ground level. So in theory, he can't go above 68.97 seconds. All right, perfect. We're going to skip 4 and 5. We're actually going to come back to them later on in this unit when we get to exponential functions. So let's look at how to find the theoretical domain. So again, you cannot divide by 0. You cannot take the square root or any even root. So square root, fourth root, sixth root of a negative number. You can, it is okay to take an odd root. That's okay. So cube root or fifth root is okay. So here I see that my function has a square root in it. I cannot take the square root of a negative number. So what that means is that what's underneath the square root has to be positive. So x needs to be bigger than 0. Because if x was -1 or -10, that would cause an issue under the square root. So my domain is that x has to be greater than or equal to 0. Notice how I'm only doing theoretical domain here. It wouldn't make sense to do practical domain on this page because there's no word problems. All right, here, what rule might I break here with x? Perhaps I could divide by 0, right? Because I have the x in the denominator. So we know that we want x to not equal 0. So we want what's in the denominator to not equal 0, because if it did, then we would have a problem. So basically, x can be any number as long as it's not 0. So let's think about this one. This problem has the same issue as A. We need what's underneath the square root to be positive. So we need v plus 5 to be greater than or equal to 0. This says in Mathanese that what's under the square root has to be positive because we can't take the square root of a negative. So if I solve, I get that my domain is any number greater than or equal to -5. If I, for instance, put in -4, -4 plus 5, that's fine. That's the square root of 1. However, if I put in a number below -5, let's say I put in -7, that's going to be an issue. I cannot take the square root of -2. So my numbers must always be bigger than -5. This one has the same issue as B. This denominator, I cannot divide by 0. So what I'm going to do is I'm going to say 2x minus 1 cannot equal 0. Because if it did, I would have a no situation that I don't want. So technically, we can solve this just like an equation. So I'm getting that my domain is all real numbers except it cannot equal 1/2. Because if x were 1/2, I plug 1/2 into that denominator, that's going to give me a 0 in the denominator, which I'm not allowed to do. So notice how I set these up. If it's a square root, I take what's inside the square root and make it greater than or equal to 0. If it's a denominator, I say that it cannot equal 0. Those are the two setups. What's inside the square root has to be greater than or equal to 0, or if it's a denominator, the denominator cannot equal 0. I want you to keep your eyes peeled for G though. Something interesting is happening with G, so you need to think carefully for that one.